This is question 11 of civil engineering paper of GATE 2016 afternoon session. A strip footing is resting on the surface of a purely clayey soil deposit. If the width of the footing is doubled, the ultimate bearing capacity of the soil. So, in this question, a strip footing is resting on the surface of a purely clayey soil deposit. If the width of the footing is doubled, then what will be the ultimate bearing capacity of the soil? So, there are 4 options given. We need to select the correct option. This question is from the topic of Terzaghi bearing capacity theory. You may study about this topic in detail in lecture 9, Shallow Foundation and Bearing Capacity, Geotechnical Engineering 2, Foundation Engineering by Professor Dilip Kumar Vaid, IIT Kharagpur. The ultimate bearing capacity is given by the equation Qu is equal to CNC plus QNQ plus 0.5 gamma Bn gamma, where C is the cohesion of the soil, Q is the overburden pressure due to soil which is coming on the foundation, and it is given as gamma into df. Gamma is the unit weight of soil and df is the depth of the foundation, and this B is the width of the foundation, and NC, NQ, N gamma are the bearing capacity factor which are given from this chart. So, here in this question the soil deposit is purely clay. So, for purely clay soil we know that phi is equal to 0, and from this chart we can say for phi equal to 0 the value of NC is 5.14, NQ is 1, and this is NQ is 1, and N gamma is 0. Now, again in this question it is also saying that this footing is resting on the surface of a purely clay soil deposit. It means when any foundation is resting on the surface of the soil, it means the depth of foundation is 0. Here in this question the depth of foundation is 0. So, now substituting all this value in this equation, we may write this ultimate bearing capacity Qu is equal to C into 5.14 plus Q. Q is gamma into df, and when df equal to 0, so this term will be 0, Q will be 0. So, this term will be 0. Why? Because if we put this df equal to 0, so then Q equal to 0. Now, again the third term 0.5 gamma Bn gamma will also be 0 because the value of N gamma is 0. So, now we can write this is 0 plus 0. So, we can say that Qu is equal to 5.14 into C. So, from this equation we can say that the ultimate bearing capacity is dependent on the value of cohesion, this value of C. So, this Qu is independent of the width of the foundation, as there is no term of B in this equation. So, we can say that Qu is independent of width of the foundation, that is B. So, we can say that Qu is independent of B. Now, coming to this question, it is saying that if width of the footing is doubled, then what will be the ultimate bearing capacity? So, just now we have seen that this ultimate bearing capacity is independent of width. It means if the width of the footing is doubled, then there will be no change in ultimate bearing capacity. It means the ultimate bearing capacity will remain the same. So, here for this question option D is the correct answer. Thank you.